This video contains more examples using the chain rule. So we're going to start with find the derivative of y equals -7 over 2t minus 3 squared. So if I did the quotient rule on this, I see that the derivative of the denominator, or my d low, would be a chain rule problem. But I also see that my d high would be 0. So it's actually easier to make this a product rule problem and bring the denominator up and make the exponent negative so that I don't have to deal with the d high of 0 terms. So I see a chain rule also when I make this a product rule, and my inner function here is 2t minus 3. So my u prime would be 2, and my outer function is -7 times something raised, or the inner raised, to the -2. And the derivative of that, then -2 will come out front. I'll get 14u to the -3. So the derivative of our entire function then is 14u to the -3 times u prime, which becomes 14 times 2t minus 3 to the -3 times 2, which we'll write as 28 times 2t minus 3 to the -3, which is a perfectly good answer, but if I wanted to write it as a fraction, so I don't have any negative exponents, it would be 28 over 2t minus 3 cubed. Okay, this example is a good bit more complicated because I see a product rule here where my first function is x squared and my second function is the square root of 1 minus x squared, which is actually going to require a chain rule. So my first function's easy. F is x squared, then f prime is just 2x. But for my g, it's a good bit more complicated. We have g is 1 minus x squared all raised to the 1/2, and then I see that I have an inner function, so we'll let u be 1 minus x squared, and u prime would then be -2x, and I have an outer function of u being raised to the 1/2. So my f of u is u to the 1/2, then f prime of u would be 1/2 u to the -1/2. So that means my g prime is then 1/2 u to the -1/2 times u prime, or 1/2 times 1 minus x squared to the -1/2 times -2x. Now, if I clean this up, 1/2 times -2x is just going to be -x times 1 minus x squared to the -1/2 power. So the derivative of our entire function is derivative of the first function, f, which would be 2x, times the second function is 1 minus x squared to the 1/2, plus the first function, which is x squared, times the derivative of the second function, which is -x, times 1 minus x squared to the -1/2. And if we clean this up, I can write it as 2x times the square root of 1 minus x squared minus x cubed over the square root of 1 minus x squared. Okay, on this problem, I actually have x over x squared plus 4 to the 1/3 power. Now I could bring the denominator up and make it a product rule, but since I have an x in my numerator and I actually will have a d high, I'm going to go ahead and use the quotient rule on this. So when I do that, I get low, which is x squared plus 4 to the 1/3. D high is 1 minus high, and D low is a little bit more complicated. For D low, I have an inner function that is x squared plus 4, and my u prime would be 2x, and my outer function would be u to the 1/3, and its derivative would be 1/3 u to the negative 2/3. So when I plug that back in here for my D low, I'm going to get 1/3 times u, which is x squared plus 4, to the negative 2/3 times u prime, which is 2x, all over low squared, which would be x squared plus 4 to the 1/3 power. When I square that, I get 2/3 power. Okay, so we want to clean this up. I have x squared plus 4 to the 1/3 power, and I have minus 2/3 x squared times, I'm going to write this x squared plus 4 to the negative 2/3 in the denominator so I can have a positive exponent all over low squared. And I did that, I rewrote it so I could see that I have a complex fraction, a fraction inside of a fraction, and I don't like that. That is not the convention in math. We don't write a fraction inside of a fraction. So I need to get rid of the 3 here and the x squared plus 4 to the 2/3. And I do that by multiplying the numerator and the denominator by those inside denominators. Okay, so when I do this, I have to distribute this 3 times x squared plus 4 to the 2/3 to everything in the numerator, and I will get 3 times x squared plus 4 for my first term. In the second term, the 3's cancel, and the x squared plus 4 to the 2/3 is going to cancel, and we just get minus 2x squared. And in the denominator, I just get 3 times x squared plus 4 to the 4/3. And if we clean up our numerator here, I see I've got 3x squared plus 12 minus 2x squared over 3 times x squared plus 4 to the 4/3. And 3x squared minus 2x squared just gives me x squared plus 12 over 3 times x squared plus 4 to the 4/3 power. Okay, this one's pretty complicated too. I have a quotient rule inside of a power rule. So it's a chain rule problem, and my inner is 3x minus 1 over x squared plus 3. My outer is just u cubed with a derivative of 3u squared. But we're going to have to do a quotient rule to find u prime. So we get low d high would be 3 minus high d low would be 2x over low squared. So if I distribute my 3, I get 3x squared plus 9 minus 6x squared plus 2x, because I have to distribute that minus to that other minus, and I make it a positive 2x over LO squared. And 3x squared minus 6x squared is negative 3x squared plus 2x plus 9 over LO squared. So now I have the derivative of my outer function, and I have the derivative of my inner function. I need to multiply those together to get our entire derivative. So we're going to get 3u squared times u prime becomes 3 times 3x minus 1 over, sorry about that, x squared plus 3 squared times our u prime was negative 3x squared plus 2x plus 9 over x squared plus 3 squared. And when I look at this, I see that this denominator of this fraction is the same as this denominator. So I'm going to rewrite this as 3 times 3x minus 1 squared over x squared plus 3 squared, because I can distribute that exponent over division, times my second fraction. And then I see that I can combine my denominators. They're the same thing squared times the same thing squared. So that'll give me x squared plus 3 to the 4th in my denominator. And there's nothing that can be combined that way in the numerator. So we just get 3 times 3x minus 1 squared times negative 3x squared plus 2x plus 9.